All right, so good morning, everyone. You're welcome. We'll be starting in a bit. So it's 8 minutes past 10 over here. That's so 10:08 UTC. And so we just want to wait for 2 minutes for some other participants to join in, and then we can start. But in the meantime, if you still have any question from the previous day, you can ask, and then we get to address that while we wait for others to get on board. Thank you. Right, so we can start. So let me quickly share my um, today's notebook and then we can move on from there. Okay, so from yesterday we're looking at the um, we're looking at how to import packages in Python and then also looking at how to make use of the packages. And we also looked at how to work with certain files. I mean, reading from the files, writing into the files, and then applying certain functions or certain um, attributes and certain actions on content of the file. We dealt with ASCII data and then also more tabular data that's structured in a CSV format. So today we'll be looking at pandas. That's also a recipe or a package that's built purely to handle tabular data. All right, so the pandas library, as we know, is purely to handle, structured data, and then this, and then we need to know that um, this pandas package is built on, you know, some basic or some fundamental recipes or fundamental packages. So for instance, you have the NumPy, Matplotlib, and then some other default, de facto standard recipes forming the framework or the baseline of the framework, and they are built upon them. And now this makes real world applications very easy. So it has various uses, and we can talk of data wrangling, data cleaning, transforming of the data, analyzing it, performing some statistics with the data, visualizing the data, and then also to store the cleaned or transformed data within another file. And then you can have a combination. The pandas as a default can actually produce its own visualization, but you can also merge that with other visualization packages like the Seaborn to make more presentable images and then easy to communicate images. Right, so in today's session we'll run through this. That's a very tall list, but we'll look at basically how to install the pandas, which we've already done that in the pre training session. That was the one that was held on Sunday. You were taken through the installation of pandas, so we'll look at how to import pandas and then go through all these, work with some data files, and then would end on the visualization, and then handling time series, and then some group by methods and the rest. Okay, so simply to install pandas, you can just use conda install pandas. That's if you are using the conda environment to install. And then you can also use pip if you're, pip is repository, sort of, it downloads from the repository and then places it on your default environment. So you can equally use pip, and pip accesses this recipe from the PyPy page, which I showed you yesterday. Alright, so just as we did for all the other packages, if you're importing pandas, you can just type maybe import pandas or import pandas as PD, or you import specific sub packages from the pandas. So maybe from pandas import something. Okay, so in this case, just as we did with NumPy, we are going to maintain the same for pandas. So we import pandas as PD, which is a standard approach, and we import, for the sake of what we'll be doing, we're also going to import NumPy as NP, and then we import pyplot from the parent package matplotlib, and we name it as PLT. Okay, and so we get to run this line, and then it imports our packages for us. Okay, so now, just as we saw from the previous lessons, if I need information on any of the sub packages or any of the packages, I just make use of the keyword help, and then help as a function, and pass that package or sub package within the help, and that produces a whole documentation. And I said, so this is one approach, and we also made mention of the fact that I can just type in my, for instance, in this case, pd.daterange. Daterange is a sub package of PD. So once I type pd.daterange, open the parentheses. In Jupyter Notebook, when I'm within the parentheses and I just hit my shift, I hit shift and tab, that should still give me the documentation, right? And we also said you can make use of the question mark approach. So question mark, then we don't bring the parentheses in the end. So the question mark approach will also produce the documentation for us. So these are various ways in which you can get some information on any package you want to make use of. Okay, all right, so we'll start off with creating data series and then data frames. So when you think of pandas or working with tabular data, you can be thinking of, say, vectors or matrices. That's the easiest way to think of it. So when you talk of a series is actually more a one-dimensional data. Okay, that means data just existing in one dimension. Now, a data frame is more of a combination of series. So it's more like having a compilation or a merger of series. And so that moves from one dimension to multi-dimensional sets. All right, and that's a key difference. So data when you talk of the series, you are looking at just one-dimensional data, which can be just a column data or a row data. A data frame is just a combination of data, the series. So that's multi-dimensional data. And so to create a typical example of a series, we have in here, so I type pd.series, which is supposed to start with a caps, that's uppercase S. I open the parentheses and then I shift tab, and it tells me what would be needed in creating the series. So we need at least the data. So we need the data itself, we need the index, and then if you want, you can specify the D type and then the name to give it sort of a variable name or sort of a column or row name. So in this case, let's say we have a list of say universities. Let's use KNUST. We have UG. Let's say we have UI. We have UCC. Let's say OAU. Okay. Now, when we just run this should produce a series for us. Okay, and it creates a default index, which is 0, 1, 2, 3, 4. They have their own default index, which is based on the position. Like we said, Python indexing will start from 0. But then we can rename this index by passing into this PD series we are creating the keyword index, and then assign some indices to it. So let's say KNUST is in Ghana, UG is in Ghana, UI is in Nigeria, we have UCC also in Ghana, and then OAU in Nigeria. Okay, and that's it. So it changes the index from the positions, which is the 0, 1, 2, 3, 4, 5, into the index we set. Okay, now bear in mind, once I move out of this cell, nothing has been assigned to any variable, so this is also lost. But then if I want to assign it to a variable, like we saw in the very first lecture, I can assign it to a variable. So let's say list of universities. Okay, and so whenever we call our list of universities, it should produce the series for us. Now, for programmers, they would always prefer, because it's very easy to confuse which one is a data frame, which one is a data, a series. It's very easy for programmers to rather precede the name, as a standard in the programming world, to proceed with maybe a DS if it's a series, and then a DF if it's a data frame. Okay, this is just for readability and then easy communication. So if you build your own set of code and you send it to another, or you share it with another, maybe a collaborator on the project, it's easier for the person to understand that, okay, this is a series, this is a data frame, but then it has no bearing on the code. All right, now if we check the type, like we said, of this variable, when we use the type method, it would give us the data type of the variable we are passing in there. So if we check the type, it tells us this is a series, okay, generated from the Pandas core, the series subpackage. So this is sort of a data series. Okay, now so that's exactly what we have contained in here. Now if we would want to create a data frame, now we can create data frames in different forms. You can create data frames using maybe lists, using arrays, using any data structure that exists. You can also make use of dictionaries, which will be way easier. So for instance, in this example, we have the dictionary data, okay, the variable name data, and we said dictionaries are contained in curly brackets. So they are quite similar to sets, but the only difference, they are similar in terms of the curly brackets, but they have a whole lot of differences. Now think of the dictionary as a normal English dictionary. You have a keyword, and then it's assigned a certain value. So for instance, in this case, you have temperature assigned all these values. We have rainfall assigned all these values. We have wind speed assigned all these values. And then say we have wind direction assigned all these values. So this is just our dictionary. Now if I go up and run this and we check what the data contains, you notice it creates a dictionary. If we check the data type, it tells us this is a dictionary. Alright. Now we are going to pass this dictionary created in the data column. So we create the data frame. Now from Pandas we are creating a data frame with the subpackage data frame. And the data frame, the D is uppercase, F is also uppercase. And the variable we are passing in here is data from the dictionary. And then if we run this as a default, okay, you would notice that it creates the data using the names as the keys as the column heads. All right, and then it passes the data under them. All right, but if for instance you did that and it wasn't working, we could then add the columns and we specify what the columns are. So columns equals to, for instance, then we call the keys from the dictionary data, and then that would be sorry, I have an extra parenthesis. Okay, yeah, because of the one I created here. So if we run that, then that should set our columns as the keys from the dictionary, which is the various keys we are having here: the temperature, rainfall, wind speed, and wind direction. Okay, and similarly, if we shift tab, you would notice that it's possible to also set the index. So we can again set the index, and let's say these are supposed to be data from different days. So let's say the first one is from Sunday, next say Monday, Tuesday, and then Wednesday. Okay, so then the indices change into the index we've set. And so it becomes very easy to identify or call certain items based on the index and then the columns that we've created. All right. Now, if we check the type of the df, which is our variable name, it tells us this is a data frame deduced from the Pandas core frame, the frame subpackage. Okay. All right. So now, if I have my data, there's our data frame. By default, if I type in df.head, that should give me the first 5 rows. That's the default. So maybe I have a huge data set read from an Excel, maybe a spreadsheet, or from any online data portal or whatever it is. And then I just want to see the first few lines of the data. So I type in df.head. Now df here refers to the data frame we called because we've assigned this to the variable name df, which I believe by now we all know. So if I type in df.head and the data sets are more than 5 rows, it will print the first 5 rows. Okay, now if I can also be specific and tell it to print maybe just the first 2 rows. So I just pass in here n equals to 2, or just type in 2 and that'll print just the first 2 rows. So this allows you just do a quick look of your data and then to know, okay, what your data contains, and if there are some issues to address, then you know what to do. And since we can do same with the head for the top part, we can then apply the tail for the bottom part. So if we try this, it picks the last 2. All right, and that's it. We can again check the shape of the data frame. So rather than going to use np.shape, the data frame by default has its own intrinsic .shape method. So I type in here df.shape, and then that produces the shape of the data frame. Just as we did for shape, we can also get the size, and then we can also get some information from the data frame. So and we can do same not just for the data frame, we can do same with our series. So for instance, we had ds underscore list of universities, okay, .info. All right, so the series has no .info attribute. Okay, but let me just try the .shape, and then yeah, so some of them, so the attributes that are explicitly so stated for the data frames and then the series would work. Okay, so for the data frame, at least we have .info, which gives us the more detailed information on the data frame, what the columns are, what the contents are, what the data types are, and then also the memory usage. Okay, and then from the data frame we can also check the column heads. That's the names of the various columns. So df.columns will produce the headers, or that's the columns. Now bear in mind, df.columns doesn't need an open and close parenthesis. All right, there's also a method, but then it doesn't need that. And like we said from yesterday, not every method would require the open and close parenthesis. Okay, all right, and then just as we did for the columns, which is the column headers, we can also do same for the row names using the df.index to generate the indices. So if we type in here df.index, it tells us our indices here are Sunday, Monday, Tuesday, Wednesday. That's what's on the left hand side of the data. That's the row names. Okay, and then as a way of a quick look, whenever you get a data, you can just apply the describe method to just give you a quick summary, some summary statistics. So df, which is our data frame, dot describe, we open and close the parenthesis, and this tells us at least the number of temperature records we are having, the number of rainfall records, the number of wind speed records, the mean data, the standard deviation, the minimum value, the 25th percentile, the median, the 75th percentile, and then the maximum value. Okay, and these are quick statistics you can then look at. So for instance, if I have a data set which let's say we have let's go back and then set one of them, maybe the temperature, to a strange value, say 9,995. Okay, and then I now apply my df dot describe. From this, clearly when you look at your temperature record, you have a mean value that's like an average of this negative value, and I mean, it will be weird to have this record as, I mean, an average temperature, and then looking through it, at least you know what the minimum value is, say in the 25th percentile. I mean, clearly you can know there's something wrong. Okay, so I can look at this data set, and then at least based on where my median is, I know what the mid value is. I know before the mid value there are some strange values, so I can then go back and see the values that are lower than the median point value, and then I can be able to check and realize, okay, this is what's causing the problem, and then do whatever changes you are supposed to do. All right, so the describe is very effective to just do a quick look in your data and be sure your data is meaningful, or it has some outliers which you would want to deal with, or other missing values and other things. Now you notice the wind direction didn't show any metric because those are strings. I mean, having northwest, northeast, and the rest, those are strings, so it's not counted as part of this description. All right, and then all the statistics you are having here, we can equally call them out individually. So we have like df.count to give us the count, and then so on and so forth. Equally, we can find the sum, just as we did from yesterday. Now we don't need to call maybe np.sum and then pass the data frame into it. I mean, we can just call the df.sum, and then we open and close parentheses, and this will give us the total of all the columns. Now you notice that in this case, this is where the wind direction gets to merge all of them together. Now what it's doing by the sum, it understands the sum from a string perspective as concatenation. All right, thinks of it as a plus. So whatever we are having here for the string just gets concatenated. All right, and we can also do a cumulative sum, which in that case means we are adding. So we pick the first value. When we go to the next step, we add the second to the first. When we go to the third step, we add the third to the second and the first. We go to the fourth, we add the fourth to the ones preceding. So we are doing more like a cumulative summation, and we can clearly see what the features are. So that makes use of the cumulative sum method. That's the cum sum, and then we open and close the parenthesis. All right, we can also find the minimum, the maximum using the same approach. Find the mean, same approach, the median. Also, yeah, and so we can apply almost all the um, various methods we already saw from the previous lessons. You can apply them onto the data frame or your series, and you would get some meaningful information from your data set. Right. Now, if I want to, you know, select just sections of my data series or the data frame, for instance, we are going to use the data frame in this case. I want to, if I want to call, you notice that from here we had these columns: temperature, rainfall, wind speed, wind direction. If I want to call, for instance, just the temperature records, then I need to call df and open the square bracket and then pass the name of the column that I need in here as a string. So temperature, and then this will produce just the temperature records. And if you check down here, the name is just the temperature. Now this is one approach. The second approach is just call your data frame dot the temperature, and this time you don't need the temperature to be passed as a string. Okay, you're only telling it to go into the data frame and pick the temperature column, and that's it. So the two options work similarly. You can use the square bracket approach and pass the variable or the column name as a string, or you just employ your data frame dot the column name, and then you're good to go. So we can equally do same for the rainfall, and then we pick just the rainfall records. Okay, and also we can use this approach. Now if I'm just selecting just the first row only, now in this case I'm not specifying the column heads. Okay, so let's say we have df 0 is to 1. Okay, now this picks just the first element, which is just the first row. Okay, so let's try this out and see. So you notice this gives us a key error, because when we use the position, when we are using just this 0 alone, it would be creating some errors. We'll be looking at another method where we have the index locator and all that, and we'll see how that works. But then if I apply the range method, okay, say give me from 0 to 1, it then understands that I'm selecting the rows based on the range method I'm using. So maybe it's from 0 to 3, then it gives me exactly the rows that I need. That's row 0, 1, and 2. And if we try this other approach, it means we are picking just the even rows. We start from 1, no endpoint, a step of 2. That's going to give us row 1, row 3. Those are like the odd rows. Okay, and that's how it works. Now when I tried the index 0, that didn't work because Pandas doesn't understand that structure. Now if I want to pick a specific index, okay, without doing the range sort of subset, and then I need to locate it, and by this I am talking of an index locator, so located by the index. Alright, so df.iloc, then I pass in the locator. Alright, and then this goes into the data frame, picks the row 0 alone. It gives us just the values of row 0. So let's print out df over here. Okay, so it gives us the values of row 0. Okay, so we can use the i.loc, the iloc, to give us just the index positioning. All right, And whenever we are using the ilog, then it means we are not making use of the names. We are going to use just the we are going to use just the indices. And so if I want to call maybe a certain position or a single value from a certain row, a certain column, and we said the comments will always separate one dimension from the other. So since I made use of the ilog, I can't use the keyword temperature and the rest over here. But rather I need to specify the index of the row I want, and then the index of the temperature, the index of the column I also want. So we know temperature is on column 0, so I pass in 0 into the second part within the square bracket, 0 into the first part in the square bracket. That gives us row 0, column 0. Where they meet gives us just that value. We are good. We can also make use of the iat method, which would be again subsetting by position. So unlike the first one, I can just, instead of ilog, I can just tell it to go to a specific position and then pick the value. So just df.iat and then specify the indices. Whenever you see the I, it means we are dealing with the index, right? And this will produce the same thing, giving us just the value. All right. Okay, so now if I want to use the labels as they are, then I don't need the ilog, but rather let's look at our df again. I would need the labels themselves, so I don't need the I just go back to the lock, and then let's see, this will produce an error exactly, because you would notice that we are not using the default indices, that's the 0, 1, 2, 3, but then our indices have been labeled. So if I make use of the lock, then I would have to specify the index also by the string name. So let's say maybe I need the data that's for Tuesday. I need just the temperature data for Tuesday. All right, and this would position itself on the temperature data for Tuesday and extract just that one. Okay, and yep, so pretty much the same. So we can also do without necessarily the square bracket over each individual one. Okay, and that works. Okay, and then we also have the other approach. I mean, so rather than passing all of them into a square bracket this way, I can also decide that, okay, first and foremost, think of it this way. First, give us all the information for Tuesday. So it brings all the Tuesday information. I'm saying after that, then pull out just the temperature data from the Tuesday records. And this will just give us the temperature records from Tuesday. And that's it. Okay. So yeah, that's just by way of it. We can also do same for data series, which I've already explained how to index based on the indices and all that. And we can use the same approach. Okay. Okay. So I believe we already have this, so I'll just skip that part. And I'm sure we'll be using the data series again. So let me just look at this from here. Okay. Okay. We had ds underscore list of universities. All right. Okay. So that's it. Okay. So exactly. So we can also use that to subset the. Okay. Um, Let me set the index back to their position. So let's see. Okay. Okay. All right, so we have it back as a default. That's a 0 to 4. Okay. And we are saying from here that we can also do a sort of Boolean subsetting. So rather than using the positions to subset a data, I can also apply a Boolean method where I use a condition, and as long as the condition is true, it pulls the data for wherever the condition is true. So for instance, we have this DS, and then I tell it to pull out all the DS values which are greater than, say, let's say 3. Yeah. Oh, I keep forgetting we are using DS list of universities. Yeah. Okay. There's a quick one. Okay. Oh, okay. 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 All right. So, all right. So let me change the parameters from strings into maybe something that is workable. Um, okay. Let's assign this to our data frame temperature records. Okay. And then let's use just the word DS so that's okay. All right. So we have a new data series. Okay. And then I need to set the index again. Okay. All right. So we only had 4 items, not 5. Okay. So all right. So we have our DS back, which is just um, a series representing just the temperature records, and we are saying that we can also subset by the Boolean approach. So let's say I have my DS where DS is greater than, say, 2. Okay, now all the values here are definitely greater than 2, so we expect them to show. So let's use a value that's quite, let's say about 31. Okay, so we want temperature records that are above 31, and this will produce only the ones that are true. Okay, so you can use this to subset. So maybe you have a data and you have a threshold. Okay, so let's assume we have data for noise levels, or we have data for pollution levels, and then we want to sort of pick out or filter data for specific locations that exceed the threshold, okay, the bearable threshold, or want to pull out data for maybe particular years that were way polluted, okay, or particular locations that are more polluted. Then we can use this approach, because if I have my data series, I can just compare the data series to the threshold. So let's say if my threshold for supposed, say temperature extreme in this case is about 31, then it means everything greater than 31 should be pulled out. So with this record, I'm able to tell, okay, this location exceeded the 31, or this particular time exceeded the 31 threshold. Okay, And we can also do same for the ones that did not exceed. So by bringing the title sign, we are saying, um, sorry, I have the same error repeating itself. Okay, so I mean, yeah, there's always a way around it. You can always use the reverse method, for instance, what is less or equal to, and then that should work. Right. Okay, and then we can also use a measure of conditions or criteria. For instance, I want um, maybe levels that fell within a particular threshold. So maybe I want temperature records that are greater than 31 and then also less than say 33. Okay, then this will pull out just the records that are above 31 and then also less than 33. If I set this to say 32, I expect it to pull just one data from the whole data series. We can also do same with a particular column of a data frame. And just as we did the AND method as a logical AND approach, we can also do same for the logical OR approach, which will produce everything as long as one of them is even true. Okay. And I already explained that we can use this method to filter our data set. So we are doing a comparison using a threshold to pull out or to filter the data. Now I can also call the entire data frame in this case, and then we are going to use, for instance, we want to pick corresponding values of a particular column item that exceeds a particular threshold. So for instance, in this case, you have our whole data frame, and I'm saying that when you go into this data frame, wherever the data frame item, which is temperature, okay, all the items under the column temperature within the data frame, which exceeds 32 degrees, should be pulled out. So when we do this, it means when this gets to be true, it pulls that whole row from the data frame. All right. So if I set this back to say 31, I expect that. Are we still getting these errors? Index of the Boolean series and of the object index do not match. Okay, let me just check what we have in here. So we have df is a data frame. Okay, so okay, all right. Okay, let me try this and see what could be the reason. Oh, that's interesting. Okay, so I think this works, but then the reason why it wasn't working for us in the first case was because of our index, which the error was telling us or prompting us that the Boolean method we are using, even though this Boolean method is justifiable, but then because of our index for the because of the index for the data frame, we are getting an error. So I think this method would work clearly better when we have our index set as default positions. So I mean it's always easy to probably generate a copy of the data and then extract. I believe there'll be other approaches or other methods as you get familiar with the pandas. You'd realize there are way more easier approaches to handling the same thing. All right. So I think I've changed the data frame back into this set. So we have our indices being the regular ID position. So that should work in this case. All right. And then we can also assign values to particular positions. So for instance, in our data, that's a series. Let's see what the series contains. Okay. So, okay. So if you have the existing notebook, that should work, because mine would be a bit different because I've changed the items in um, the data, the series, and then the data frame creation. So for instance, I can pick the item number one because my index in this case will be slightly different from what you have in your existing notebook. You might be having day one, day two, day three. Mine will be just 0, 1, 2, 3 in that order. So if I'm going to select a particular index, say DS index 1, and then assign a value of 6, then I expect that the item number 1, which is the item with the index 1, should be changed. So if I go back to the data, I notice that this changes from the existing value to a value of 6. All right, and that's it. We can also again use the ilog. We said we can use the ilog to identify the element at an indexed position. So I pick within the data frame first dimension, first element, I mean the first element on the first dimension, the first element on the second dimension where they intersect. I pick that value and then I reassign it the value 34. And then we expect that now when we go into our data frame, the first element should be evaluated to 34. Okay. So while we go on, if there's any question, you can still bring them up so that we can address them. And then we also talked about the fact that once we build a function, we can apply the function to, data frames, series, and whatever you're having, based on the Pandas approach. And it becomes, so we looked at functions in two forms, as the default function build, and then also the lambda expression approach of building functions. Right, so we have this method where we are using the first approach of building functions, so which is the default. We have the def being the keyword to tell us we are building a function, and then the function name double, we open the parenthesis and keep the argument in there. The dummy argument here is x, and we are producing a y dependent on x, that's multiplying x by 2, and we return in here that y, which is supposed to be the x times 2. So simply we can just, instead of equating this to y, simply just return x star 2, and that'll give us the double. Now if I'm going to apply a function for a data frame, and they are not dependent on themselves, they are standalone, a function that applies to them standalone, then it means we can make use of the log method or the ilog method to extract the items, or to indicate that these are the items that I want to apply this function to, and then we make use of the apply method, and in the apply method we pass the function. Okay, so within this apply method we are going to pass in the function. So first and foremost, let's be sure that this is going to pull out our data frame as such. So let's see our data frame again. It has temperature and then the rest. Okay, so at least we are picking all the rows, and then for the columns we are just pulling out just the temperature and then the wind speed. And so we would be applying the double function to just the temperature and then the wind speed column. Okay, and so if we look at this gives us just our temperature and wind speed information. So if I apply the function, that should work on just these columns. So if we try applying this, and then that's it, and we have the values doubled. But bear in mind, if I go back to my df, it will still be the existing one. Nothing changes within the data frame, because even though you apply the function here, you didn't pass it back to the data frame. But if you wanted to overwrite it, if you wanted to replace those values, then it means you have to reassign it back to the data frame, so that when we do that, then it's going to replace those values and then assign them back. Okay, all right. And then we also have here a sorting method, so we can sort by index, that we use the index to do the sorting. So if my index or the indices were sort of unsorted, we can use the index to sort. And we can also sort the data by, or the data frame by, a particular column. So for instance, we indicate that the data should be sorted by the wind speed. So it means it's going to go in the increasing order. And you notice the 3 and 2 get swapped because 3 is lesser than 2 for the wind speed. Okay. And we can do same by nesting, two columns. So that means they should sort by the first one, and then when it's done, also sort by the second. So then it's more like it's going to be dependent on the two. And then that's the procedure. So it started off by the temperature and then sorted the temperature records. All right. So indirectly, it means it picks the first one. If the first one doesn't, if the first one had some duplicates, all right. What this would have done is if the first one had some duplicates, then it means for those duplicates, it would go and look at the second item and see which one is smaller and then place that one above the other. Okay. And then once we are sorting, we should know that in sorting, the values by default also have ranks. So it's going to use those ranks to sort the data and know, okay, this one is the smallest, this one is the highest in terms of their magnitude. So we can then just look at the ranks and know, okay, these are the ranks by which the data would be sorted, or these are their respective ranks based on the magnitude of the values, the magnitude of the data we have for each particular cell or column and row. And then we can also drop values. So we can drop values along, we can drop an entire row, drop an entire column. Bear in mind, the row has a default axis of 0, which is the first dimension, and then the column has a default of 1, which is the second dimension. So we can drop. So in this case, let's say I have DS being indexed by 0, 1, 2, 3. So I can drop the series by a particular index. Say maybe I don't want the first value to show. So I go into my data series and then I drop and I indicate which position to drop. And that gets kicked out of the data. Right? And then again, like I said, if you just do this, it doesn't get stored. But if you want it to be stored, you then have to reassign it back to a variable, be it the same DS to override that or a different variable. Okay. And then we can do same for the data frame. So for instance, I have my DF, all right, and then I get to drop. Let's try this. And then we have the first row going off. But then if I'm going to drop by a column, then it means I would have to specify, for instance, in here, I specify, okay, let's drop the rainfall data. And if I try this, this will produce an error because the index, the rows do not have any label as rainfall. So this will produce an error. But then since this is rather on the column, I need to specify here an axis and equate that to 1, telling it that, okay, we are using the column rather as our reference. So look through the column and then where you find rainfall, you drop that. Okay. And then again, if you want it to be saved or you want it to be stored, you want to write that back into a new variable or to override the existing variable. And that's how the drop method works. Okay. So we have some extras to try our hands on and then you can see how it works. Okay. So there are some examples for your consumption. And then we also indicated from here that we can replace certain values. So we can apply the replace method and then indicate which values to replace them with. Okay, these are quite basic things. So now in this case, it's like we are being specific. We have the wind speed. We call the wind speed value that we want to replace. For instance, under the rainfall column, the value we want to replace, the temperature column, the value we want to replace, and then these were cast as dictionary and then replace them to, by the nonce, and they get replaced, and that's all. All right. If there's any question, we can take it before we move on to the time series? If there are any questions, we can quickly take them before we move on to the time series. All right, so I assume we are also trying it out with our notebook, so it's quite okay. Now, when it comes to time series, we are dealing with data that has, a time axis, and that's all. So, in order to create a time axis, we can use the pandas method, that's the to underscore date time, to convert a particular date into a datetime format. Now, for instance, if I have this is a string, okay? If I check the type of the data type of this is just a string. But then if I want to format this into a datetime, Pandas understands that, this format can be a date. So if I call my PD, then I indicate to underscore datetime, this converts the string into a timestamp. Okay, and we can do that for different date formats. So different date time formats, uh, list of dates, and then we can also even apply the particular format we want to write. So we specify in here, for instance, that these are supposed to be formatted as month before day before year. These are the structure that the data I'm passing in here. The first item is a month, followed by the slash. Then the next one is a day, followed by the slash, and then the year. All right, and then it gets to convert them as such, and that's the output we are having down here. Okay, so there's one approach. We can also create a range of dates, which we'll be looking at in a bit. So we also have the dateutil package, which we can use the parser sub package from it to pass a date in a different format into a timestamp. So for instance, I have my date being 4th of July 2015, which is a string. I make use of the parser which we imported .parse, and this passes this into a date, and then I can just create the to date time on the date. It's also very easy to just not go through the whole step, rather type in your pd.toDateTime and then pass in the string of the 4th of July 2015, and it will just convert this to a timestamp for you. Right? Okay, so you can change any date format into a timestamp so easily. And then if you want to create a range of dates, we can also then make use of the pd.dateRange. So pd.date underscore range, and then we'll specify in here, for instance, I want yearly data from 1900, okay, to say 2022. So I go one step higher, and then I would specify the frequency in here, that there should be a yearly data, right? And this just produces the data from 1900 all the way to 2022, and these are yearly data. Okay, so from this to the next year to the next year, on and on. All right, now when you just type in your pd.dateRange and you hit your shift tab, it tells you the various methods you can use. You can use a period approach, you can use a frequency. So by periods, you can specify just the starting time, indicate the periods maybe as 5 periods, so it will give you just 5 time steps from your reference date, and that's it. So there's a whole lot of documentation on this which you can look at and then get familiar with the date time under the pandas. All right, so in this example we are creating monthly timestamps from 1980 January 1 all the way to 2020, 2021. That's our focus here is on December, so since it's 31st and we're starting from 1, it should produce the December data also for us. Okay, so we have that tested down here, and then that's it. It gives us the monthly data I mean, in those formats. Okay. So in this case, for instance, in this particular one, we didn't specify the frequency, so we expect that the default will be used. The default was, which is the daily frequency. But if we wanted the monthly, we would then have to specify the frequency in here and indicate as a string caps M, which is the monthly information. Okay, sorry, I passed it in the wrong place. It should be within the datetime parenthesis. Yeah, exactly. So then this gets executed as a monthly datetime for us. Okay, all right. And you notice that some end in 31, others in 29. I mean, those are just the end of the month, the day, I mean, the number of days within that particular month. Since there's a monthly data, it picks just the last day of the month, and then, but we can format this and then just show it as purely month and year only. Okay. All right. So now we are going to add just some random data to the new data frame we've created, which is this monthly data frame. All right. Or let's even still maintain this as a daily, so we can pass in just a D. And our data frame is a daily data set, so we have the date already created. And then we can use numpy to create random numbers. So we have np.random.rand n, which is to create random negative and positive numbers. And then let's try to understand this in bits. So within this, the random numbers we are trying to create, we are first getting the length of the new data frame we created. That's a date column. So go into the new data frame and then pick the date column. So just this one. That's the df new.date. Should produce just the date. Alright. And I said we can use this approach, or we can use the square brackets approach and then pass this as a string. They should work the same way. Now after getting this, we find the length of this. That's which is the same as the size. Okay, and we find the length. From there, now we generate the random numbers using np.random.randn over these lengths. So that means create random numbers of this length, and that's exactly what we've created. And so when we created that, we just added a value, I mean a magnitude of 20 to it. So it will just be the values we had plus 20 in each case. And then whatever the output is assigned to a new column called random values under the df new. Bear in mind, when we do this, if this column existed, that's the column random values existed, then it's going to override that. But if it's not existent, then it means it would recreate that column. So we have this column created, and we can then check our df new, and we see it contains the date and then the random values. All right. Now, df underscore new, if I pick the date, for instance, okay, let's see the type. Okay, first let's take the df underscore new dot date. Okay. All right, since this is a date time, it means this will work well as a time series if you want to visualize it. But then the only problem we would be having in this case is that our index is not the date. So if I decide to plot this, okay, it will look a bit weird because all the two columns will be plotted separately on, even though it's going to be on the same chart, but then it will have no reference to a time series. It will just be like, okay, we have dates plotted, random values plotted, and they are plotted by the index. But then since we know that our date is already in a time series, we can set the date as the index, so that when we plot the random values, it will be dependent on the index which we would have set as our date. So if I have this, I can employ the set underscore index, right? And then I tell it to set the date as the index. All right, but then I would need to save this into the df underscore new so that it gets stored. So if I do this now, I have my data frame stored. And then if I decide to plot it, so my df underscore new dot plot, then I can see my time series. Oh, sorry. Okay, so the reason why we are getting this error is that I had already set the index to date. That was what I just ran. I set this index to date. So if I try to reset it, because it's already set to the date, it doesn't identify the index as a new column that we can reset to the date. I don't know if it's clear. Let me try and visualize this from here so you get to see it. So when you look at this df underscore new, the date used to be a column in here, and we had the index as the positions, the 0, 1, 2, 3, on and on. But then in the very last one, I set the date to the index, so it got overwritten, and we saved it. It was overwritten, and we saved it to the df new. All right, that gave us the override. Now, if I try to reassign these in what we are doing here, I try to recreate the random values, and then override the random values in the column random values, but then there's no new column called date. So if I try to set the index to date, it looks within the columns you're having, there's no date column. All right, because the date is already the index, and then the index is not part of the columns that we are working with. Right, the index is just the positioning. So in this case, this date has become the positioning, not a new column, so we can't reset it because it's already existent, but then we can still visualize it and see what it contains. Um, just a quick one, let me check what I have in here. Yeah, sure. All right, no need to. Okay, so it means I have to go back and rerun it. Um, so I think aside the index that was given the error, also I've made use of the length of df new.date here. So I expect that to also produce the same error because it still cannot identify the date. Okay, so let me rather use the index. So df new.index, so that it creates based on the index instead. Yeah. Alright, so I have to pass this back. Alright, okay, yeah, that's it. So then if we plot, we should expect the random values plotted out, this time against our time. Alright, so the moment you would want to have a time series, that means your index should be sort of reconfigured into a timestamp, so that when you plot it out, it knows that, okay, I'm dealing with timestamps. And if you check your time aspect, and then it's not having a data type or a d type of a date time format, then it means what you would produce wouldn't be a time series. It would just be, it might look to you as a time series, but then they might not be so uniform. It wouldn't go in a progressive time approach. So if you want that, then it means you have to set your data index to the time stamp, so that then it's easier to visualize the time series. All right. Okay, so we've already gone through this part in the very top section, but if you downloaded a notebook, then it means you would have to run this separately, and then that's exactly the same thing we did up there to produce um, our time series plot. And once we have the time series and we've set our index as a timestamp, it means we can extract some basic information from the timestamp. For instance, I just want the year information for the timestamp. I can extract that and indicate, okay, so go to the index of my data frame, that's df underscore new, and then within that index just extract the year from the timestamp. So even though we have data for, different days, it will just extract the year component of all the days. All right, and we can do same for the month, which will just extract the month component of all the dates. Do same for the days, and so on and so forth. All right, and then we can use the sample method to randomly show any, you know, number of elements. So if maybe I want to sample just maybe any 10 elements from the data, I can just use the df dot, I call the data frame dot sample and then specify how many random values to, just produce, and it will just go into the data and randomly pick them. So you have no control over which ones would show. They are just random values that are pulled out. Okay. All right. So okay, and then since we have a data frame, that's the df new, we have its index, its indices being a timestamp. It means we can also extract for particular dates. So maybe within this whole data, which is from 1980 to 2021, I just want 1984. I can pick my df underscore new and then subset by just the year. All right, and this will just pull out just the 1984 information. You notice that these are just 1984 data, and so we can also do same for a range. Say from 1984 to 1989, we get the data set. So this will pull out 84 data all the way to 1989. So we can use the same subsetting method within a timestamp, sort of a time series, to extract particular aspects of the data and then visualize it or work or perform an action on it. All right, we've already seen how to visualize the plot by just typing in the dot plot method. And that's one approach. Okay, now if I just subset the year, the data by a particular year and plot, I expect that I won't have, all this, sort of noisy data. I'd rather see data visualized for just that select year. All right, then I can see what happened within the year in terms of the profile of the data. Okay, and then we can also be specific and say, okay, rather than just 1984, go further. Okay, pick just data for 1984 March. That's March of 1984. Pick just data for that period and then visualize that. And that becomes also way smaller because we have just a certain number of days within that period. And bear in mind, we can also use the range approach. So from 1984 March to say 1984, let's use say July. All right, and then we can also just subset the data and then visualize and apply functions and different methods to it. And that's what we have here. Okay, and okay, I think that's quite a similar example here. And then yesterday we saw how to generate plots using the subplot method, where we specify the columns and all that. So in this case, we've already dealt with the first one. So the second aspect is what we are going to look at. Now in this case, I want, within this data set, I'm picking all the data that comes before all the way to 1989. That means I want data from the starting period all the way to 1989. Okay, so if I test just this part of the code, we would have data from 1980 all the way to 1989. Okay, now after getting that, I want to plot it. So if I decide to add the dot plot, it just creates a plot. But then what if I have a subplot? So in this case, we have, for instance, the fig, the axis. So the axis is supposed to create 2 columns, so it creates 2 columns. Now I want to position that particular plot I've generated into a specific location. Now knowing the location or the row and column sort of identifier of the subplot, I can just pass in this keyword, which I explained yesterday, the AX, right, and equate that to, or assign it a value of the axis position we want to go to. We said this is one dimensional because we only specify just the columns. Now I want it to go into the first column, right? So just pass in the axis. So it picks the axis or pulls the axis from the axis we've set here, and then it subsets the axis and picks just the first axis and would assign the AX to it. So the first plot goes into the first axis, which is the 1980 all the way to 1989. And then the second plot, we are just plotting data for 1989 to 1990, which is just 2 years. And want this data to be visualized on the second half. So we then specify within the plot our AX and then set the axis on the second column to the AX. And so we can regenerate this and then we have our plot. And I told you yesterday that that's the beauty of this subplot method. So you can actually, let's say I want this in the first one, I want this in the second one. Sorry, I want the top one in the second one, I want the down one in the first one. I can revert them and then I'm good to go. What if I want all of them in the same location? Then I can just specify and then it gets created like that. Okay, so I have more control using this axis method. All right. Okay, so similarly, now we've been talking so far about you creating your own data sets and then working with them. But what if we are having data within, say, a spreadsheet on the internet somewhere from a file we want to make use of? So I'm going to deal with CSV files, for instance. Now, if you want to read the data under Pandas, there's a functionality or there's a method called read_CSV, which would read data from a CSV file. You can also read data from a spreadsheet, which is an Excel file, using the read_Excel method. We'll look at some other examples of the read_Excel in some few steps below. Alright, so we've already seen these three, so no need to go back. We define our path, locate the file itself, and give it a file path. Now I want to read data from this file, which is the tamale crew_rainfall.csv, which should be in your data folder if you've already updated the data we've uploaded onto the GitHub page. I mean the GitHub repository. Yeah, so I make use of the pd.read_csv, and then I would specify the file path. Okay, or I'll specify the file itself in here. And then if there's a separator, I would indicate the separator using this keyword sep. And in this case, the separator is we use commas to separate one column from the other, so we specify the comma in here. Now if you want to see all the functionality within the read_CSV method, you can hit your shift tab and it tells you which other attributes you can use. So headers, use calls, skips, and then all that, skipping rows, skipping columns, headers, a whole lot. Alright, so if we run this, now this should read our data from the file we've specified and then split them column by column and pass the output to the file name ACSV. Alright, now if we look at our ACSV, we can see what it contains. So maybe I want just the first 5 rows, so .head. By default that will produce the first 5, so let's say the first 8 rows, so 8. And then we get to see what the data contains. So it contains this is actually the year information, but it's headed as PRE. So we can, using the replace method we saw, we can use that to replace it. And then we notice that the various columns are respective year information, right? Respective month information. So each column represents a month data for the respective years, which are supposed to be the columns. The supposed to be the rows. The respective years are supposed to be the rows. The months are the columns. Alright, so we can apply the rename method, and then we are renaming our columns. Okay, and then on the columns we are telling it to rename the precipitation or the PRE with the variable year, and then we apply the in place method to be true so that it keeps everything exactly as it is. Alright, we indicate that in place should be true, so it keeps everything as it is and just replaces the PRE with the year. And then when we run that, we get to see that everything else stays exactly as it is the PRE alone gets to be changed from PRE to year. And then what we did next in here, which we've seen before, I mean the things that we've already done, I'll just be brushing over them. So we pick the year column and then set that as our index. So we can use this approach, which is just say, okay, acsv.index and equate that to the year. Or we can also use this method, which is the acsv.setIndex. And then we specify the index in here as the year. And we rewrite that back to the acsv. Okay, so if we rerun this and then we check what our acsv is, we have it configured, and then the year has been made the index. Okay, so there's one approach, and we can also use the second approach, which is, sorry, I've already done this, so no need to rerun that. So we can also use the second approach, which is just picking the year and then assigning it to the index. And then when we are done, because we've assigned this to the index, the year still is maintained, so we can drop the year. And bear in mind, we are doing a column drop, so we have to specify the axis as 1, so that it drops along that whole column of year. And then that has already been set to the index. Okay. And once we are done with that, we can decide to, we are collapsing the columns. So if we collapse the columns, it means we are going to have data for every individual row. So we are doing more of a column averaging. So I mean a column summation. So we have the acsv.sum, which is supposed to find the total. So if I have just acsv.sum, it would add up the whole data and give me just a unit value. Okay. Right, so this is supposed to rather give a column, I mean by column it gives the sum, but that's not what we want to do. We want to rather find the yearly totals. So it means we want to keep our rows intact and rather add the data along the columns. So we specify our axis in here to be 1, so that it knows that, okay, we are adding over the columns instead. So if I regenerate this over the axis of 1, then it means the columns are dealt with, they are added up, and we know, okay, this is information for every particular year, say from 1901 to, I mean, the most current year. Okay, I mean, there's a very easy way of dropping this missing value, so I mean we can deal with that later. And then if we are done, we can decide to plot, and we have a yearly totals. And then in here we've set the y label. So unlike the first one, which we were using the plt, the matplotlib direct, then we had to do plt.set or plt.title, plt.label. We can just set in here the y label, set in here the x label, set in the title, set in the limits and all that directly, and we would have our information showing. Alright, so we can also do same using the averaging method, and this time we are doing an averaging where we collapse the rows. So we are going to have monthly climatologies or monthly averages, and then when we generate this, we rather have all the months kept intact and then their mean data over the period. Okay, alright, so that's just by way of some application of some basic or intrinsic methods like the sum, the mean over columns or over rows, making use of a time series data set. There are some examples here which I believe when you try your hands on them and you face any challenge, it will be easy to work with you on them from there. So I would entreat us to try our hands on it, and then I would give some time, maybe some 2 minutes for some questions if there are any, before we move on to the second part. So if there are any questions, I'll take them now before we move on to the second part. Any questions, please? You can type them in the chat also so that we get to address them. All right, so if there are no questions, we would probably move on. Now we are going to do the same thing as we did in the first approach. This time you are working with an Excel file. Okay, I mean a spreadsheet. So there's a sample spreadsheet which we called the testrr underscore tntx underscore data dot slx. And we are going to call this making use of the pandas, and then in place of, I mean, for the visualization, we would also make use of the Seaborn package to see how simplistic it is to use the Seaborn to produce these same plots and then also apply them. So we import Seaborn. I mean, by default, most people will just call it as SNS. So in most write-ups and most coding, you see this as SNS. So I mean, we can stick to that or use just the SB. And then there's also in Python, there's also the ManKendal package, which purely is a trend assessment package. So you can use that if you're doing some statistics and you want to look at the ManKendal trend in your data. All right, that's, I mean, because it's applicable in virtually every field. If you're working with real-time data, I mean, project data, you would want to see, you know, some statistics, some trends, some significance, and then, I mean, how the trends sort of vary seasonally, ordinarily, and all that. So the PyManKendal is one you can also make use of. There's also the stats model, which you can use for various statistics. I mean, your hypothesis testing, your a whole lot of statistics. You can make use of them. All right. Okay, so we import these packages. That's our Seaborn and then our PyManKendal. And we already have the pandas installed. Okay, so I use the path method to specify the path of the data, and then in here I redirect the path. I go into the path and then also pick the file I want, and then I'm naming that file as the file name as just the file path underscore spreadsheet. Now for me to use the pandas to read the data, that's the spreadsheet, I just make use of the pd underscore read Excel. Okay. Now when you type in read underscore, you notice there are various read types you can use. You can use read underscore clipboard to read data as a clipboard. I mean, Excel, CSV, Fedora, FWF. You can read data from a web page using a read underscore HTML. I mean, a JSON, and even from a database using the read underscore SQL and so on. Like a whole lot of, even from an XML file, you can read data. All right. So we make use of the read underscore Excel to read data from an Excel file, and when we shift tab, we can see what it contains. So we need to specify the file, we need to specify the sheet name. So if my Excel file has multiple sheets, I have to specify which sheet I'm going to pull the data from. By default, it will pick the first sheet if I don't specify. But then if I'm specific, then it would go searching for the particular sheet name I specified. Then the other attributes we can set in there, which is fairly near to what we did with the read underscore CSV. Okay, so we would apply the read underscore Excel method on our file, which is now named as the file path underscore spreadsheet. So we read data from this file, and then we specify the sheet to go to. So the sheets are named RR, TN, and then TX. So the first one, we are reading the RR from the file we have. So it goes into the sheet named RR and then picks the data from there. And then, I mean, in some cases, you might be having an error. So you need to specify what sort of Excel, I mean, engine to adapt or to use in opening the file. Okay, so there are various engines you would want to use, but this is quite reliable. So you can just use this open PyXL, and that should work for you. So we set our engine so that I use that open PyXL to open this file and then read data from the RR sheet name, and that's same for the TN and TX, and we name them as DFRR, DFTN, and DFTX, which are different files. So now if we want to see what they contain, we can check, for instance, DFRR, and then we look at the head, and then the first 5 lines we have information. So we have, for instance, the name. Now to explain what this data contains, I think it's already detailed down here, but the first one is the station name, second one is the parameter that is being assessed, the next is the year, we have the month, and then the various data. But bear in mind, the column names that we have, val01, val02, are representing respective days. Alright, so we can actually change this val01, val02 to the particular day, numbers. Alright, so that has been detailed in here. So exactly, we've checked that. So we can also reshape the spreadsheet data. Now I'm going to explain this in a bit. I think one of the challenges I had at first was, maybe you have data of this form, you want to stack the data. So if you look at the data, maybe it's in this form, but I want to have just maybe a column data where instead of having, for instance, I go into 2010 January, then I have all the respective days. I want it to be 2010 January 1 all the way to January, January 1, the first day, all the way to December 31st, all in one column. Okay, so we would want to stack the data. Now in order to do that, we can make use of the melt method, which Pandas provides. So I pick the data frame. Okay, if it's too fast to, please let me know so I can just take my time a bit. So we have the data frame, and then we call the melt method. Okay, so df underscore rr, which is our data frame we are using, dot melt. All right, and within this melt we have various variables we can set. So I would need to set the ID vars, which are the ones that will be held fixed. Right, those variables will be held fixed, and not, they will just be like the ones that are determining the happenings of the other unfixed ones. And then I'll indicate the value vars. These are the values that will get stacked. Okay, so when they are melted, those are the values that will be melted. When they are melted or stacked together, then we can specify those values there. And then we can also, if by default I don't specify, it means all the remaining variables that are not in the ID vars would get melted or stacked. And then we can specify the variable name. So after they are stacked, the column that they would fall within would have a column name. Right, that's think of it this way. From the data we were looking at, when we are done stacking all these ones, these columns would have to be recreated as also a column. The column names you're having would have to be recreated as columns on the side, so that at least when it picks 2010 January, it would stack all from day 1 to the end of the month, go to the next month the same way. So these columns are going to get stacked. So the var name we are having will be the name for the columns that are up here, which get stacked also in a separate column. And then the values themselves, which will be stacked, we then would also have to indicate the value name if we want to. Other than that, by default we'll name them value, and then the var name by default we'll name them variable. Okay, so in this case, for instance, we are holding the vars, which is name, the station abbreviation that we had, the year and the month constant. So if we run this, you'd notice that the data has been stacked. But it started from, maybe we have the station, the RR, the year, the month, but then they are not in any particular order because we expect it to start from, say, January 1, January 2, on and on, but it's sorting them rather by the variable. So because the var 01 was picked first, that was melted first, then var 2, var 3, on and on till it gets to var 31, which is the day 31 in the various columns. So when we are done with this is just to melt, and then we see their respective values. Okay, their respective values are kept by the sides. But then, even though this has been melted or sort of stacked, the order isn't exactly what we want, so we need to reorder them. So first we want to rename these variables into just the value. So for instance, I want the variables which are val01 to be changed into the day. So if it's val01, I want it to be day 1, and then val02 should be day 2, val31 should be day 31. So we apply a sort of formatting here, and then I tell this to format this val whatever the day is. All right, it should create a sort of a dictionary. It's creating a dictionary that picks the various vowels as keys. So we have val, say whatever the day is, which is a key, and then that will be assigned to the value itself, which would be extracted. The value will be extracted from that val. Okay, and so the value would then be the value assigned to that respective key, starting from 1 to 32, because we had a whole 31, I mean sort of from 1 to about 31 columns up here for the vowels. So we had val01 all the way to val31. Alright, so we specify from 1 to 32 to create those respective replacer sort of replacer values. And then when we rerun this variable fields to rename, we have the list generated, which means in the place of val01 we'll have it's assigned a value, say 1, 2. There's only a dictionary created, so we'll then need to do a renaming. So we are going to rename those within our df underscore rr. So we can do that after we've melted, or we can do that before we melt. So I'm just taking us a step back where we get to rename the columns by the field names that we've created, okay, which are these names, and then we use the in-place method so that it is kept as such. So if we rerun this, we go back, we see that our columns are named into, instead of the val something, it rather keeps the day numbers. All right, and so we can go back and then do our remelting on the ones that we've now reassigned. And then the variable name, which is replacing the column element, we are naming that as our day. And then I can decide to name the value as whatever variable we were merging together or sort of stacking. So let's say we can pass in here value name, and then we call that maybe RR. Okay, so when we are done, now we all know that not all the days are 31, not all the days are like 30, some are 29. So wherever there isn't data, but because we have a fixed length of 1 to 31, it will still create for all of them 1 to 31 for the various months. But then where there's no data for that respective day within that month, it would be left as none, which is a missing data. So we have the ability to drop all the nones so that the ones that are false dates get dropped. So we apply that here after melting. We apply the drop NA to drop all the missing values, and then we can then rerun this, and we get to see that, I mean, the nones are dropped. We have our data still intact. All right, and we then would convert the year, month, and day into a date time. So that's this part, the year, month, and the day. Now when I apply the to date time, I expect that that should then sort them out in a proper date format, because in this case, even though they are still arranged, the nones are dropped, but they are not arranged properly. We have 2010 January 1, then 2010 February, but I want it to be January 2nd, on and on and on. So we need to convert these ones into a timestamp, and once it's a timestamp, it knows, okay, times are supposed to be progressive. So we apply the pd.toDateTime, and if we apply that on the data frame and the columns, that's year, month, and day, we expect that to create a time step for us. Okay, so we can create that time step and then call that maybe a new column date. And so when we go back into our flattened data, we would have the new column date set. Right, it's created as a timestamp, and then once we have that, it means we want to drop the year, month, and the day, and then we can set this date as our index, which should do the ordering properly for us. So we either would drop, or we can decide to select just the ones that we want. So in this case, in the next example, we rather selected the name the value, and then the date. So out of all these ones, we are picking the name, we pick the value, which is in this case RR, because I have named it as RR from here, where I set the value name as RR. But if you have the default notebook, it means this wouldn't be set, so by default it would be the value. So if I want to extract, then I would have to extract the name, the RR that I extracted, and then the date. And then I'm setting the date as the index for this data frame. Okay. And so that's exactly the whole step. And then this whole melt method, actually you can also use the same pivot approach, which will work just like if you've used Excel before. I mean, you creating a pivot table, it's virtually the same thing. So you can use the approach also to recreate this whole data set, and then we have our data structured properly. I mean, let me go back and change this value to RR. Yeah, and then we have our data structured properly for us. Okay, so a combination of these ones would give us virtually what we have in here, so we can nest the whole steps together, and then we would have that. Now the data was just for 3 locations, but at different time steps or different timestamps, and that's exactly what we've done. So we can do this, and rather than doing it maybe for multiple files one at a time, I decide to rather pass that into a function and call that function maybe reshape from month rows to daily, something like that. And so we passed everything that we have into this function, and then in the function the only thing we do not set here is the value name, so that we know we can apply it to say different data sets. So if we rerun this, we have our function built, and then if I pick that same function that we've built in this case, which we applied for the RR, I apply that onto my TN data set, which is the df underscore TN we created. We should also have that sort of reshaped. We do same for the TX. There's our TX in its default state. We can also reshape the TX. So we can reshape all these ones just based on the function that made use of the melt approach and then the pivot approach. Now I have a bit more of detail on this. So when you go onto the metadata page, I think there's a video on the melt and then a combination of the melt and then the pivot that also has been put up there. I'm sure when you look at that alongside this one, if there are any queries, you'll be able to ask us, and then we'll be able to assist you. All right, and this should help in all your data wrangling. So all we've done so far is just to play around with our data, to wrangle the data into a format that we find it very easy to use. And so if I give you data in this format, at least this is quite easy to look at the data and then just, I mean, create something from it. So let's say even without thinking about it, I can just quickly plot this data set, and then I know I'll have something more meaningful. All right, rather than if I want to generate a time series from the way this data is. I mean, this would be a bit complex to try to create. I'll still, even in Excel, I'll need to still create a pivot table and then pivot them up before I can work with that. So I can simply do that, or we can simply do that in the in sort of like a function, making use of our melt and then also our pivot, and then we are good to go. The melt and then our pivot, and we are good to go. Right. So if you also need some extra information on what data wrangling could be done, I mean, you can check up on these links, and then they will be quite useful. We only have barely some 8 minutes to go by. I'll still take some questions if there are any before we move on. All right, so if there are no questions, we can go ahead. Seaborn is also another package that's purely for visualizing the data. So it creates more, I would say, fanciful and then some realistic, I mean, data visualization for you, which you can use, I mean, for your publications, for presentations, for, I mean, policy work, and also engagements with people or stakeholders. Yeah, so like I said, Seaborn is also built over the default of Matplotlib, right? And you can use pip or conda to install that. And so for instance, I want to generate a KDE plot. So for the data that we had, let's say in this case, I've already imported my Seaborn as SB. Okay, so I call my sb.kde plot, which is a sub package that generates a Gaussian sort of kernel density plot, okay, from the Seaborn. And then I'm calling just my Kumasi data, but bear in mind this is my Kumasi data, okay. And then the as type, which I explained from lesson 1, we are formatting this as a float, all right. And then we are telling it to generate a KDE plot using the Seaborn package of this Kumasi data, which we've formatted as a float. We don't necessarily even need to bring the as float. That should still work because our data is already a float. And then we can plot it. And the legend in here is only to create a legend. Okay, we are setting the legend to be true. And then we can set the shading so that the kernel density would get to be shaded with the same color of the line, or we set it to false, which is, I think the default is a false. Yeah. So this creates a kernel density plot of our Kumasi data, where we can see that most of the precipitation information we are seeing are just very low rains or even no rain at all, and then just a few extreme cases which could probably produce some maybe floods and all that. All right. Like I said, the default of the shading is always set to false, and this is how it will look. All right. Okay, so we can use that same KDE plot and sort of produce same for multiple stations, and then add some formatting, a combination of our matplotlib legend approach, and then the X labels and all that, and that should perfectly work for us. We can also use the the Seaborn. You can also use the Seaborn to generate some scatter plot, and that's very simple. Now, if I have a data frame, it's very simple to generate the um, scatter plot from the using the Seaborn approach. So this is a data frame df underscore rr underscore by station. Okay, so this the data frame we had. It has separate columns. Now on the scatter plot, I need x and then I need y. So we are going to call our SB, which is a Seaborn dot scatter plot, and then we can specify that my data should be this df underscore rr underscore by station. So I'm going to use this data frame, and rather than specifying okay this and that, I need to just set in here, because when I call the data to this data frame, it pulls out this whole data frame, and it's only waiting for me to tell it which one should be the x, which one should be the y. So maybe I want x to be, let's say, Tamale, and then I want my y to be, say, Tema. All right, to produce a scatter plot, and that's simply what we have over there. And this the same thing we've done using the Kumasi and Tema data to generate a scatter plot. So you can use the Seaborn for various visualization types. There's a whole lot of documentation on that, so it's quite easy to, you can also generate joint plots using the same approach we used for the scatter plot, but we change this to joint plot, and this will produce histograms on the top and then the right hand side. So histograms for let's say the x-axis information, and then histogram for the y-axis information, and then we can set the kind right to different formats. So if you hit your shift tab within the joint plot, you should be able to find the various plot styles we can set our kind to, right, and a whole lot. And you can also even use the hue approach to set your colors, so that maybe the colors that you're having won't be fixed, they will be varying based on a third column or a third parameter. All right, and so we set this to hex, and this should create some hexagonal plots for us, and that's it. Docus, can we still go on? Do we still have some time to carry on? All right, so maybe if you could spare some few minutes. So we can also group our data set. So we had data of time series. So if you look at our data frame, for instance, that's our df underscore rr by station. Let's pick the index. We have time series. So maybe I want to do a grouping. I want to group the data by maybe the respective years. Okay. First, we said we can just select the years. That's the dot year. But this doesn't necessarily, find maybe a grouping or something like that over the years. But maybe I want to find yearly sums or yearly totals. Then I'll need to make use of a grouper class to group. All right, and then the grouper or the group by method doesn't only work for time series. So you can group data by any categories you decide to set. All right, so if your data has multiple categories, you can use those categories as the grouping criteria. And just as we are going to use the grouper class to do a group by method, we can also use the resample to resample the data. The two have a lot more in common, but there are also some minor differences which I wouldn't go into the detail now for time's sake. But I believe if you try your hands on it and you come across them, you can also share with us. Okay, so how it works is that in the group by case, we call our data frame and then we add a dot group by. That means this is telling our data frame we are going to group it by a certain category. All right, and then in here, because we are grouping a time series, we just make use of the grouper class, which is a pd.grouper. So this grouper comes from pandas, and then we'll specify how to group it. Say the frequency, we set the frequency to year. That means you should group them just by the year. So it picks every year as a category, and then we'll group all the years together, and then we can then decide what we want to do. So maybe I want to aggregate the years using the np.sum. I want to find the summation. So then I can aggregate the groupings I've done and then find the sum, or maybe find the mean. I can find the np.mean. All right, and it's the same. You can also do same for monthly, maybe different time um, ranges, and then again we can just use the plot to visualize. But then the resample method just means we have the data frame, which is quite simple. We have the data frame, then we add the dot resample, and then we indicate how we are going to resample it, whether yearly, monthly, quarterly, whatever approach you indicate. And then what you want to generate or produce, maybe you want to have the sum, so you can add after it dot sum to create, say in this case, in this example we have monthly resample, so dot sum, that's monthly total, and then yearly resample dot sum, that's like yearly or annual totals. Okay, and that's clearly what we've done in here. So we do not think of the whole joint plot, but just look at the data part. So we pick this data and then we apply the group by method. We group it on monthly basis and then we find the sum, so the monthly summation, and then this would work within the whole the pandas data frame. It would apply it onto all the columns. All right, and then we are making only use of the joint plot to select the Tema component, the Kumasi component of what we've created, and then visualize that, and then that's what we have produced as the information down here. And then we can also have some pair plots. This is just to quickly look through your data, and then all the diagonals are always going to be histograms because they are is the same data set along the diagonal. So this is Kumasi against Kumasi itself, and in that order. And then the other ends will be scatter plots. Right. I think the others I wouldn't go through them now. Maybe if we meet tomorrow, we might take time. By then, you would have probably gone through what we've done. Yeah, I think 1 to 15 is quite good. So that at least, hopefully, tomorrow when we meet, we can, if there's time, we can just touch up on these parts. And then if there are some questions, we can address them before we even touch up on this, so that it doesn't feel too rushed. I know it's already a lot, but you would have to bear with it because it's just a 2-hour session and we have limited time to cover a lot of things. All right, so I'm going to end here, and then hopefully we'll continue that tomorrow before we move on to what we have for day 5, if there are no questions. So if there are any questions, I would like to take them now before we move on. So, any questions, please? All right, so if there are no questions, I'll be ending here. And then I hope that as we try our hands on it, probably um, we'll get some questions and then we'll be able to um, interact even beyond the class. So I'll be looking forward to you trying your hands on it and then getting us some feedback on how it fared or how you are faring with it. And if you have any issues, don't hesitate to get back to us. I mean, in the very first um, lecture material, you would see our contact indicated. You can reach us via mail, and we'll be able to assist you. We look forward to hearing from you. All right. So since Dorcas isn't here, I would like to take the opportunity to officially bring today's session to a close. And I wish you all the best of the day. If there are no questions, yes, yes.
Yeah, Jeffrey, look at it here.
Oh, okay, sure. All right. So Dorcas, then over to you.
Yeah, sorry, my laptop went off. So we want to thank you again for the for thank you so much. That was great as well for today. And we want to thank all our participants as well. Tomorrow is the last day, so please kindly invite your friends on board. And we still have the video on YouTube. The channel is Meteo Data. Kindly subscribe to the channel because there are other Python lessons there as well you can follow up. Yeah, so tomorrow at 9:30, facilitator and other mentors will be in this room to answer all your questions, and at 10 o'clock a.m. exactly, our last day starts. So thank you all once again. Dr. Jeffrey, thank you.
All right. Thank you. So hopefully we meet tomorrow. Okay. Bye.